In March 2013, a research expedition finally penetrated a 600-meter-high granite fortress on Australia's Cape York Peninsula. At 14.2833 degrees south, 144.5167 degrees east, surveyors identified an entirely isolated vertebrate ecosystem within days of arrival. Standard satellite optical imagery registers the Melville Range as a sterile, hyper-arid desert of exposed black boulders. This data misses the reality of the terrain: 120-meter-deep subterranean voids that house ancient Gondwanan rainforest endemics. This geological architecture is a lithophilous microrefugium. The jumbled boulders provide a thermodynamic buffer that protected these taxa during millions of years of continental aridification. The existence of this biome requires a re-evaluation of ecological modeling. Macroclimatic data alone can overlook high-density evolutionary hotspots if they are shielded by structural topography. The animals found here present a specific evolutionary contradiction. Their genomic blueprints date back 15 to 30 million years, yet their physical forms are specialized for this exact rock matrix. Salturius eximius, the Cape Melville leaf-tailed gecko, displays structural elongation, a narrow head, and exceptionally long limbs designed for vertical granite locomotion. Its cranial architecture features unusually large, unpatterned gray eyes, an adaptation for light gathering deep within the boulder voids. The blotched boulder frog, Cophyxilus petrophilus, also possesses massive eyes relative to its small 30-millimeter body size. C. petrophilus has bypassed the need for open water, laying its eggs directly in moist rock cracks, where the tadpoles develop entirely within the egg. The Cape Melville shade skink, Saprosynchus saltus, features elongated digits that indicate a long-term evolutionary association with rock surfaces. Lithophilic isolation drives these specific phenotypic traits, while the stable internal microclimate maintains the ancestral genomic structure. The batholith formed 285 million years ago during the Hunter-Bowen orogeny, when deep crustal magma intruded into the upper mantle and cooled into crystalline granite. During the Triassic period, erosion stripped away thousands of meters of sedimentary overburden, exposing the granite. Mid-Miocene aridification later trapped the remaining rainforest mantle inside these surviving uplands. The modern scree field contains interstitial boulder cavities up to 120 meters deep. This architecture serves as a thermodynamic shield. Multi-band thermal infrared telemetry shows that internal cavities maintain temperatures 6.2 degrees Celsius lower than ambient midday peaks on the surface. The granite matrix serves a dual function. It is an impermeable barrier to macrofauna and a continuous hydrologic sieve for subterranean moisture. Without this high thermal mass insulation and moisture trapping, these Gondwanan relics would have faced extinction. Global databases often suffer from homonymous nomenclature, which corrupts spatial analysis. The Queensland batholith is distinct from the Cape Melville Formation in Antarctica, an early Miocene sequence characterized by fossilized marine bivalves. It is also frequently confused with the Melville Range Nature Reserve in New South Wales, an 843-hectare open woodland, and a UK artificial gallery shooting range. Failing to disambiguate these entities results in failures in automated biodiversity indexing, rendering the true Cape Melville refugium statistically invisible. In 2018, high-resolution airborne LiDAR mapped the entire 150-square-kilometer Melville Range matrix. Mappers required a density of 28 points per square meter to capture returns from the complex boulder angles. A canopy penetration rate of 12.4% allowed the survey to bypass surface vegetation and document the hidden topography beneath. The data revealed collapsed stolines and massive subterranean depressions that standard satellite photography cannot detect. Advanced remote sensing provides empirical access to a microbiome physically sheltered for millions of years. The speciation of these endemics was shaped by the hydrologic fluctuations of the Pleistocene. During the Eemian interglacial peak 120,000 years ago, high sea levels converted the range into an island, severing gene flow with mainland populations. By the last glacial maximum, 20,000 years ago, sea levels dropped 120 meters, leaving the range surrounded by a hyper-arid savanna plain. Throughout these extremes of flooding and desiccation, the internal scree voids remained stable, serving as an evolutionary life raft. These oscillating pressures restricted speciation to this pile of rocks, resulting in lineages specialized to these specific geological parameters. The high water mark is often used as a jurisdictional baseline to separate terrestrial environments from the sea. However, the same sea level fluctuations that isolated the Melville Range also submerged the surrounding coastal plains. This history creates a physical link between the terrestrial batholith and the now underwater shelves. Indigenous geosophical knowledge recognizes this link, treating the batholith and the submerged coastal shelves as a singular living continuum of sea country. This cultural and biological heritage is now the focus of international protection efforts, such as the proposal to list the endemics under CITES Appendix 2. While the granite shields against invasive macrofauna, these lineages remain dependent on the stability of the internal microclimate. Survival relies on the structural integrity of the hydrologic sieve. If internal moisture levels drop, the microrefugium collapses.